What I intend to demonstrate here is how you can use a spreadsheet program. I'm using Excel in this case. This will work equally well with most any spreadsheet. I've tried OpenOffice and a couple others. What we're going to do is simulate and test some algorithms for software synthesized audio. We're going to be able to test some techniques using Excel to kind of play with our algorithms here. So I'm just going to show you briefly, real quick, how we can create waves from equations and analyze them in Excel. So let's just go ahead and dive right in with a quick introduction here. So the first thing we need to do is decide what sample rate the whole project is going to be at. Sample rate's important because you need to know how much time has elapsed between each sample when you're synthesizing your wave. So let's do sample rate, and we're just going to use 44100. Just a default sample right there. So the first thing we need to do is basically come up with a pseudo variable. We're just going to use a column that determines how much time has passed in our algorithm. So we're going to just do a 1 second sample. We're going to start, of course, with 0 being the start, and we're doing is calculating time here. So all you're going to do is take the sample before, or the time before. So in this case, it's going to be A1, and you're going to add the inverse of the sample rate. So 1 over, and we'll use an absolute address for this. So that's F $2. So we're going to get, of course, an exponential number there that's hard to see what it is, and not really important because we're going to actually look graphically at the output. Now, you might have noticed I said I was going to do 1 second worth of samples. That is, if you look at their 44,000 samples. How are you going to get that formula copied down that many times? Well, it turns out it's really easy. So we've got the cell with our formula in it, and all we need to do is use this tool here to actually select the samples, or the column number. So if we can go from A to, I have caps lock on, let's try again, A to A4401, because we're going to go all the way to the 1 second mark here, and press enter. And we're going to use an option called fill down. You can't see it here, it's kind of cut off because I'm using a shortened window size here for recording, but you'll find it in different spreadsheets under edit, usually fill down. The shortcut in some, including Excel, is Control D. So I'm just going to go and hit that, and it's copied my formula straight down the list. So we can prove really quickly that that's working correctly. Just while it's selected, generate a line graph. Quick and dirty, we get a straight line going from 0 to 1 second. Exactly what we wanted to do. So let's get rid of that and do our first useful thing. Let's go ahead and do a very basic wave function. We'll start with the sine wave. So if you recall, a sine, full cycle of sine is going to be actually 2 pi. So if you just do sine, you're not going to get a full cycle. So I'm going to do sine 2 times pi. Pi is a function in Excel. Now we also need to reference the time point we're at to know which point of the wave it's drawing at each specific sample. So we just reference the time before the time slot we're in. So let's do times A1, and that's going to give us our first sample point. So we'll do the same trick to copy that formula down the list. So B44101, press enter, Control D. That's copied down. Now, if we go to insert line graph, we should have one complete sine wave. And there we have one sine wave. So we have a function. Let's go ahead and make this useful, because we're going to want to play with numbers when we play with different algorithms that we're going to do. So the first thing I'm going to do is make it so that we can change the frequency of the wave. So I'm actually going to do 2 waves. So freak 1 and freak 2. And I'm going to set a value for each of those. So we need to work the frequency into our algorithm. Of course, you would for any sound synthesis. You're going to want to do that. Now, when you do research for this, or if you follow the research that I looked at, almost every equation you'll see for generating waves is going to use frequency times time to generate the sine wave. I'm going to go ahead and do that here because that's easy to do, quick and easy to do. But you're going to find that that's going to give you some problems when you get down the road. So we'll go into that a little bit later. But for now, let's just go ahead and put that into our equation. And then we'll analyze this and see why it's not a good idea for what we're trying to do. But we're going to just multiply by our frequency, which is again a absolute address, h2. And now we want to mix a second wave in there. So all we have to do that is copy this equation, copy, and add it, same equation, and just reference our other frequency. So that was H2. Nope, sorry, I. And the other thing I want to do, I want to keep my sine wave between -1 and 1. So I'm actually just going to take the whole thing and divide by 2 so we have that same scale when we do this. So we're going to do the same thing to copy that equation back down. So B44101, enter, Control D. And now if I generate a line graph, it's kind of hard to see as it is now, but there's two waves mixing together. So to make this easier to see, we can actually play with our numbers now. I'm going to change the primary wave to 4. Once again, hard to see, but if we make this one really high, say 20, you can start to see that there's two waves connected together. I'm going to go ahead and make this even bigger so it's much more clear. Oops. Go back up here, change this to 40. And it's very easy to see that we have two waves, one right on top of the other. So now that we have two waves, we can start playing with our filters, high-pass, low-pass filters, and analyze how well our algorithms are working using Excel. So that's all we're going to do for this brief introduction, and next we'll come back and do some filtering.